Hello, good day. I'm Sir Pentadecagon, and I'm going to discuss solving quadratic equations by extracting square roots. So this is for grade 9 mathematics. Let us have the objectives of our lesson. Review square roots. Apply extracting square root method in solving quadratic equations. Yeah. Okay, so let's first review square roots. So I have here the first 10 numbers. If you're going to multiply it by itself, there is the product. So you have 1 times 1 equals 1. You have 2 times 2 equals 4. All the way to 10 times 10 equals 100. And you will notice that square root of 1 equals 1. Square root of 4 equals 2. Square root of 9 equals 3. Up to square root of 100 equals 10. So you will notice that the answers earlier in getting the product by multiplying the number by itself, and once we get the square root, it will return to its original number. So say you have square root of 36, which is equal to 6. That means 6 times 6 equals 36. There's a note here. When getting square roots of the numbers that are perfect, there are two possible answers. One is positive, the other is negative. So let's say square root of 49, that is equal to positive negative 7. Okay, so this is how the square roots lesson works. Of course, this already discussed during lower grades for grade 9. Okay, so you already have the prior knowledge about square roots. Now this is our lesson, solving quadratic equations by extracting square roots. So I have here examples of quadratic equations that can be solved using extracting square roots. Okay, so let's have the first example here. X squared equals 81. So all we have to do is it goes like, what number represented by this variable, if you're going to square that number, the answer is 81. So we're going to apply extracting square roots here by extracting the square root both sides of this equation. So you have here the square root of x squared equals the square root of 81. So what happens here is just cancel the square root sign and square, giving you x equals square root of 81 is positive negative 9. So there are always two answers here. One is positive and one is negative. Now we are required to check if this answer, which is called the roots or the solutions, will satisfy the given equation. So if x equals 9, we just substitute the value of x to 9. So 9 squared equals 81. 81 equals 81. In the same manner, if x equals negative 9, negative 9 squared equals 81. 81 equals 81. Okay, next we have here b squared minus 64 equals 0. Here, you will notice that there is a number on this side that then equals 0. So what we're going to do is to apply the addition property here by getting the additive inverse of this number, which is negative 64. So the additive is positive 64. So you have to add plus 64 both sides. So negative 64 plus 64, that's already done. That's 0. 0 plus 64 equals 64. Then we apply the extracting of square roots on both sides of the equation, cancelling the square root, sine and square, that will leave you b, and then of course square root of 64, that is positive negative 8. So these are the roots of this quadratic equation, which is positive negative 8. So we're going to check these roots. So b equals 8, b equals negative 8, using the given quadratic equation. So you just substitute the value of b. So that's 8 squared minus 64 equals 0. Then the other one is negative 8 squared minus 64 equals 0. That will give us both 64 minus 64 equals 0. 0 is equal to 0. So that means once the equation or the by checking you arrive at the same answer, the roots satisfy this given quadratic equation. Okay. Next, let's say you have 2m squared minus 98 equals 0. So here you will notice that there is a number beside the given variable m, and this number here equal to 0. So the first step is you have to get the additive inverse by applying the addition property of equality here to negative 98. That becomes plus 98. So both sides, you're going to add plus 98 on both sides. So negative 98 plus 98, it's already 0. 0 plus 98 equals 98. Then the next step is, since there is a numerical coefficient beside the variable m, we have to divide both sides of the equation by 2. So 2m squared divided by 2 is m squared. 98 divided by 2 is 49. And then that's time we have to extract square roots. So m is equal to positive negative 7. So I'm not going to show the checking anymore, since it will be done for you. And anyways, if you're going to check plus minus 7 in this equation, in this quadratic equation, it will satisfy the given quadratic equation. Okay, next we have 2p squared equals 50. This time you will see that the given number or the constant is already on this side. So what we're going to do is to you have a numerical value here beside the variable p, which is 2. So you have to divide both sides by 2. So p squared equals 50 divided by 2 is 25, and then we take the square root both sides. Since square root of 25 is perfect number, you can take the square root of that So the answer is positive negative 5. Okay. Next. Now, there are some cases that the given equation is like this one. You have the quantity of x minus 4 squared equals 169. Now, we can apply here extracting square roots by directly take the square root of both sides. So, you just cancel the square root sign and square, giving you x minus 4. Then, square root of 169 is positive negative 13. Then, to cancel negative 4 here, since we are looking for the value of x, we have to add the additive inverse of negative 4 both sides, so that is positive 4. So negative 4 plus 4 here is already done, that is 0. Now we have here two roots. One is 13 plus 4, the other one is negative 13 plus 4. So the first root, or the first solution, is 13 plus 4, that is equal to 17. Negative 13 plus 4 is negative 9. Now let us try to check if these two satisfies the equation. Of course, as you can see here, if you have x equals 17, just substitute the value of x here. 17 minus 4, quantity squared equals 169. 17 minus 4 is 13. 13 squared equals 169. 169 equals 169. If x is equal to negative 9, negative 9 minus 4 is negative 13. Quantity squared equals 169. 169 equals 169. So therefore, these roots satisfy the given quadratic equation. Okay. Let us try to analyze this given equation. We have here x squared plus 18 equals 0. Now, just like what we are applying earlier, we have to apply the addition property of equality here by adding the additive inverse on both sides. So, since this is positive 18, the additive inverse will be negative 18. Okay, so 18 minus 18 here will be 0. 0 minus 18 is negative 18. Now, you will notice that s squared equals negative 18. Now, what happens if we take the square root of these two both sides? So, of course, we have the square root of s squared, which is s. But, on the other hand, on this side, there's no such thing as the square root of a negative number. In this case, the square root of negative 18. So, therefore, there is no real solution or roots, since there is no real number when you squared gives negative 18. Okay, so there's no such thing as if you take the square root of a negative number. For that instance, there is no real number, hence there is no real solution or roots. Now, to summarize, the method of solving quadratic equation in the form x squared equals k is called extracting square roots, that can be solved by applying the following properties. Number 1, if k is greater than 0, then x squared equals k has two real solution or roots. That is, x is equal to positive negative square root of k. Number 2, if k is equal to 0, then x squared equals k has one real solution or root, that is x is equal to 0. And then if k is less than 0, then x squared equals k has no real solution or roots. Just like in our last example, if the given k is negative, then there is no real solution or roots. Thank you for watching. I hope you understand the lesson extracting square roots. Don't forget to click the subscribe button, Pentadecagon. Thank you for watching. God bless.